More important for us is orbit stability. So orbit stability is weird because we are indoctrinated in stages. So we were indoctrinated by Newton to only look at infinitesimal deviations, which are called Newton's equations in various forms, and go march forward in time. And now I'm telling you, no, every orbit, you have to look at it everywhere for all points on the orbit. And you have to understand the stability. So we don't have intuition about it. But temporal stability we understand, because temporal stability, it's here described by this little low-dimensional matrix. It said, I have few degrees of freedom. I kick them at the beginning, and I look what happens to neighbors. And that's described by linear as neighborhood. And forcing them to come back gives me this condition, which results in 1 minus Jacobian matrix. Simplest thing you can say about neighborhood is compute the volume of the neighborhood. That's done by determinants. And here comes an amazing result that Hill discovered, and then Poincaré turned into a much more powerful proof. And that is that this determinant, which is a very high dimensional field, so I have a capital D here as opposed to little. So this is maybe 2 by 2 matrix. This is maybe 1000 by 1000 matrix if I went 1000 steps. And the volume obtained by this determinant equals the time volume. So even though this guy means perturbation every place, zillion eigenvalues, when you look at the volume of the neighborhood of the orbit, they agree in a very precise sense. As we have been indoctrinated in time evolution, we tend to compute this because, we understand what it is. It's a linearized neighborhood. It's being stretched around the orbit in time. And we don't tell anybody that we are not able to compute it, because very quickly, this kind of matrix develops exponentially large and exponentially small numbers, which run out of any register of any computer. So we actually, when we compute it, we cheat. We go in little steps. That's called multi-shooting, and do this and that. So what we actually do is we're computing the guy on the left-hand side, but we never told anybody this.